Welcome to this explainer. Look, if you've been anywhere near enterprise tech lately, you know we're right in the middle of a massive shift in how AI systems retrieve knowledge. But with that shift comes an absolute wall of jargon and frankly a ton of hype. So today, we're cutting straight through all that noise. We're going to demystify three of the heavy hitters in modern AI knowledge retrieval: vector RAG, GraphRAG, and OKF, or the open knowledge format. If you're an architect, a developer, or really just someone trying to build AI that actually works in the real world, you are exactly in the right place. Here's a quick look at our roadmap for today. 1. The competitor myth. 2. Vector versus graph search. 3. Building the architecture. 4. Open knowledge format. And 5. The ultimate strategy. Let's get right into it.
Starting things off with Section 1, the competitor myth. Right now, there's this massive assumption out there that is literally causing decision fatigue across the entire tech industry. You might be staring at a whiteboard right now, asking yourself, are vector RAG, GraphRAG, and OKF competitors? People tend to think they have to pick just one to win the AI race. Do we go all in on a vector database? Do we build a massive knowledge graph? Do we just wait for OKF to mature? It kind of feels like a high-stakes, multiple-choice test, where picking one means missing out on the rest.
Well, the short answer is absolutely no. They are definitely not enemies. In fact, they are highly complementary pieces of a much bigger, more robust puzzle. The source material is super clear on this. The absolute strongest enterprise architecture doesn't just pick a winner, it systematically combines all three of these frameworks to cover their mutual blind spots.
So, let's unpack our toolkit a bit, starting with vector RAG. What's it actually good for? Well, vector RAG finds semantically similar content. At its core, it retrieves things that just sound similar to your query. It is an absolute workhorse for low-cost, low-latency semantic discovery. If you have a fuzzy question, or you just need to find a specific chunk of text across thousands of documents, vector RAG is going to be your fast, reliable go-to.
Next up is GraphRAG. Now, unlike vector search, GraphRAG retrieves things that are connected through explicit, known relationships. It really shines when you need to walk a complete impact chain. For example, a vector search could easily find your payment API, but GraphRAG, it can track a change in that API's event schema all the way downstream to a specific regulatory report. It's fundamentally all about multi-hop reasoning.
And finally, we have Google's new open knowledge format, or OKF. Now keep in mind, this isn't a database or a search engine. It's a portable, version-controlled standard for representing your highly curated knowledge to AI agents. Think of it more as your foundational map rather than the vehicle itself. It uses simple files to build a really lightweight graph, setting the stage for everything else you do.
Which brings us right to Section 2, vector versus graph search.
Now that we know these tools aren't competitors, let's see how they actually build on one another in the real world. This table brilliantly illustrates when to use which tool. If your question is a direct fact lookup, like what does create payment return, vector RAG is excellent, and honestly, GraphRAG would just be unnecessary overhead. But if you ask an impact question like if payment authorized changes, what systems are affected, vector RAG is probably going to miss those indirect consumers. That is exactly where GraphRAG is excellent. Just keep in mind, GraphRAG brings considerably higher cost, latency, and maintenance complexity to the table. You really only want to use Graph when the answer relies on those deep connections.
We do have to address the elephant in the room, though. GraphRAG is not magic. Its biggest weakness by far is graph quality itself. If your entity resolution is off, say your system confuses a payment service with a payment table, or if the LLM decides to just fabricate relationships, GraphRAG will spit out incredibly authoritative-looking but completely incorrect answers. And a noisy graph is honestly worse than having no graph at all, because false confidence at the enterprise scale is super dangerous.
Moving on to Section 3, building the architecture.
Okay, so to avoid those exact pitfalls, the source provides a really deliberate 5-step blueprint for implementation. Step 1 is absolutely vital. Start with questions. You need to create 100 to 200 representative questions and classify them. Are they direct fact lookups or multi-hop reasoning? Doing this will tell you if you even need GraphRAG to begin with. Then you define your constrained ontology, build your evidence and graph indexes, use hybrid retrieval to keep things tight, and constantly evaluate those results against standard vector RAG.
Let's actually zoom in on step 2 for a second, because this is where a lot of projects tend to fail. You have got to define a constrained enterprise ontology. That means strict guardrails. For nodes, you might strictly use categories like service, API, event, or incident. And for edges, the relationships, you strictly define them as calls, emits, consumes, or governed by. The golden rule here, do not let an LLM just invent unlimited relationship types on the fly. If you let the AI hallucinate its own ontology, your graph is going to turn into an unusable, tangled mess.
And for step 3, building the index, what's really fascinating here is the absolute necessity for provenance. Every single graph assertion must point back to original evidence. You have to track the exact source document, the specific text chunk, the extraction timestamp. Never ever allow your AI to answer from a relationship that can't be traced right back to a specific source. That is exactly how you guarantee trust in these enterprise systems.
All right, section 4, enter open knowledge format. So where exactly does Google's OKF fit into this whole complex indexing pipeline? Well, OKF uses simple Markdown and YAML to create a lightweight graph. But here's the kicker. It is strictly for your highly valuable curated architectural map. OKF is for stable knowledge, stuff like service responsibilities, API contracts, and architectural decisions. It is unequivocally not for your constantly changing operational state. Please don't dump logs, live transactions, secrets, or massive raw document archives into it. It's meant to be a clean, curated map, not a raw data dumping ground.
Which leads us nicely into section 5, the ultimate implementation strategy.
Let's bring this all together into a highly pragmatic action plan you can take back to your team today. If you're building an IDE chatbot, your strategy should look exactly like this 4-step process. First, put your OKF knowledge right beside the code in your repos. Second, instruct your agent to always read that OKF index.md file first for any architecture questions. Third, just let the IDE's native semantic search handle standard code retrieval. And finally, step 4, only bring in external GraphRAG services when you've proven that native retrieval is missing critical multi-hop relationships. Treat OKF as the map and only bring in the heavy graph artillery when it's absolutely necessary. The source material delivers this incredibly blunt warning, and honestly, you might want to screenshot this. Don't begin by automatically GraphRAG indexing your entire enterprise. Look, it's so tempting to just throw all your data into a massive graph database and hope the AI sorts it all out, right? But that's just a recipe for high costs and hallucinations. You can get most of the value without first building a massive, expensive context platform, just by starting with a curated OKF map.
So, as you look at your own enterprise architecture, I want to leave you with this final provocative thought. When you start your next AI knowledge project, will you blindly index everything and just hope for the best? Or will you take the time to build a curated, reliable map first? The technology is definitely here, but the strategy is completely up to you. Thanks so much for joining me on this explainer, and I'll catch you on the next one.